Hey guys, what's up, people? Welcome to the session. How are you guys doing? How are your preparations going? First of all, a very good luck to all of you guys who are giving your final exams. I know that these are some scary times. You guys are skeptical about what kind of questions are going to appear. But again, as I always say, don't focus on what you can't control, and that is especially the kind of questions that you're going to receive. But what you can control is how much you're prepared for the exam. So good luck for that, guys. Welcome to the session. We are back with the one-shot series of work, power, energy, where we are going to complete the entire chapter in one shot, in one stretch. And more importantly, we'll be solving some questions as well. So get your pens and papers ready. Note down everything that is important and make sure that you refer to those notes as well once you're preparing for your exams. All right. So all the very best. With that said, let's begin without wasting any more time. So work, power, energy in one shot is the topic for today, people. These are the topics, these are the subtopics that we're going to be covering in today's session. Scientific work and its numericals, kinetic energy and its numericals, potential energy and its numericals, law of conservation of energy and numericals, power and commercial unity or unit of energy and numericals based on that as well. So let's begin, people, without wasting any more time. Now I want everyone to give me 100% attention, because again, it's an important chapter, and more importantly, you can expect a lot of questions from this. So it's better to be prepared than to be sorry later. So without wasting any time, let's begin. Here we go. The first thing I would like everyone to do is take a quick screenshot of this mind map. This is the entire syllabus of work, power, energy in one shot. Let me just quickly take you through this. We'll be going through all of these one after another, but just for your reference, this is what we're going to talk about today. We'll understand what is work, when is work is said to be done, what is energy, we'll understand what are the types of energy, potential, kinetic, light energy, sound energy. You've seen a little bit of this, but we will not be talking more about that. We'll be talking more about the mechanical energy, that is potential, and kinetic energy is what we're going to talk about. Then what is what is the formula of work, what is the energy, how do we derive the conservation of energy via a formula, and apart from that, we'll also talk about power and the commercial unit of power, and how to calculate how much is the energy consumed and all that, right? So that is what we're going to talk about. So you can take a screenshot of this case. This is the entire syllabus. With that said, let's begin with the basic syllabus of what is work. See, guys, according to physics, scientifically, work is said to be done when force applied on a body creates or produces some displacement. For example, let's say that I'm pushing this wall. All right, I'm giving my 100%. I start sweating. I'm losing energy after maybe an hour. I'm feeling hungry. But does the wall move? I'm no Hulk. It's definitely not going to move. The wall is still going to stay there itself. So according to science, according to physics, there's no work done. So when is work said to be done? Work is said to be done when the force applied on a body creates some displacement. In this case, I'm applying a lot of force, but then there's no displacement. So I can say for a fact that there's no work done according to physics. Now, I might feel like I'm losing a lot of energy. I'm sweating and everything. But then, according to physics, there's no work done. So the formula for work becomes W, which is nothing but work done, is equal to F into S, where F is nothing but the force and S is nothing but the displacement. Now, force, as you guys already know, is nothing but mass into acceleration. So you can also write it as M into A into S, which is nothing but mass times acceleration times displacement. So this is the basic thing that you must know about. So yes, guys, so when you apply a force, if the resultant displacement is also in the same direction, obviously that is when work is said to be done, when the body is moving or is getting displaced. So in order for you to do some work, you have to transfer some energy to it, because what is energy? It is the capacity to do work. So you must have some energy. It's not like you're doing it just like that, no. It's not like we have some inner yin yang wala thing. It's not like that. There's energy within us, and that energy that you get from eating food and stuff, that energy gets stored inside your body, and that energy is what is converted or is transferred in order for you to do that work. So work is done when you satisfy two conditions. One is that there should be a force applied on it. Obviously, you can't use your mental force, like yeah. Let me just stop with a superhero reference. Anyways, so the force there should be a force applied on it, and secondly there should be a displacement as well. Only if there's displacement and there's force applied, then you can say that work is done. So work is equal to F into S, or force into displacement is the formula. So if you talk about the unit, guys, you know that force is nothing but Newton and displacement is nothing but meter. So Newton meter, which can also be written as joules, is the unit or the SI unit of work. And work is a scalar quantity, which means that it does not depend on the direction, no matter what. It does not, like whether you are pushing it towards the top, down, it does not really matter, because work done is not really a vector quantity, it's a scalar quantity. Now there are three types of work. You can have work said to be positive, it can be zero, or it can be negative as well. So when is work said to be positive? When the force applied and the displacement is in the same direction, that's when work is said to be positive. For example, let's say you're lifting up a box. The force that you're applying is also towards the top, and the displacement obviously is also towards the top, because the box is getting displaced from the bottom position to the top. So that is positive work done. Zero work is done when the force and displacement is perpendicular to each other, when it's at 90 degrees to each other. The reason why this is zero, think about it, guys. I'll tell you why. Because, guys, the actual formula of work done is force times displacement cos theta. This is the actual formula. Now we don't right now we just learned as force into displacement. The reason is, guys, because in most cases than not, what we do is that we apply the force and displacement in the same direction. So when you apply force and the displacement is also in the same direction, what is the angle between them? The angle between them is 0, and cos 0 is nothing but 1. Cos, if you think about cos, the value of cos 0 is nothing but 1. So when you put it in the equation, you'll again get it as F into S itself. But in these kind of situations where the work done and the force and the displacement is perpendicular or at 90 degrees to each other, cos 90 is nothing but 0. So cos 90, value of cos 90 is 0. So the whole term then becomes 0. This is the reason why, guys. This is why if the force and displacement is at 90 degrees to each other, work done is said to be 0. Negative is when the displacement and force is in the opposite direction. For example, let's say that you're trying, the force, let's say that you're trying to push up a box, but then the box falls down. So which way is the displacement? Displacement is downwards, but the force that you're applied is upwards. So in that case, the work done is said to be negative, because force again is a vector quantity. You consider the direction as well. So you see that, sorry, displacement is also a vector quantity. Displacement is a vector quantity. So what happens is that it goes in the opposite direction, and you see that work is negative. Alright, so yeah, people, that is the first part of the topic. That is the basic stuff. Now let's quickly solve this question and then move on to the next one. Alright, the question is this: if a force of 1 Newton is acting on an object that is moving through 10 meters in direction perpendicular to the force, what is the work done is? Okay, what is the work done? 1 joules, 10 joules, 100 joules, or 0 joules. So work done is equal to force times displacement cos theta. Now they've clearly mentioned that it's perpendicular. So what is it going to be? So force is 1, displacement is 10, cos 90, which is nothing but 0. So the whole term becomes 0. So what is the work done? Apparently it's 0. No matter how much you do, according to physics, the work done is said to be 0 in this case. Even though there's displacement, even though you're applying a force, because the angle between them is 90 degrees, work done is 0. Alright? So yes, people, now that you've understood this, let's talk about energy. What is energy? Energy is nothing but the capacity to do work, or the capability to do work. Again, measured in terms of joules itself. Alright? So if you have more energy, you do more work. For example, let's say that you're cycling. You cycle more faster. Like, when you start the cycling process, like, when you, let's say that you want to cycle 10 kilometers. In the start, you'll do really fast. You'll cycle really fast. You have a lot of energy. You just eat food. You have a lot of energy. You're like full on bubbling with a lot of energy, and you want to just get it over with, and you apply a lot more force, and basically you do more work. But then when you have less energy, as it nears towards the end, as the 10 kilometers are coming closer by, you have lost or exhausted a lot of that energy that you had in the start, and energy becomes less, and so the work done is also going to be less. So energy possessed by the body can be measured in terms of the capacity to do work. So basically, in other words, if you're doing, like, in order for you to do that work, you need to spend that energy. So you can measure it that way. So the amount of work done that you measure can be actually used, or the capacity to do work can be used in order to measure the energy that is possessed by the body. Now you have different types of energy. You have the mechanical energy that we are going to focus on today, that is potential kinetic energy, heat energy, chemical, electrical, light, sound, all these are different forms. Again, heat energy is nothing but the energy that what to say, that flows from hot objects to cold objects. Chemical energy is nothing but the energy possessed by the body due to chemical reactions. Electrical energy because the flow of the electrons. Light energy because of the which enables you to see things. Sound energy which enables you to hear things. So all of these are different. You have different type. You have geothermal energy. You have so many types of energy. Let's talk about this one for now. Let's talk about kinetic and potential. Kinetic energy is nothing but the energy possessed by the body by the virtue of its motion. When a body is moving, the energy possessed by that is what is called as kinetic energy. So greater the velocity, greater the kinetic energy. So because like for example, imagine there's a car which is coming down a slope and there's a box at the end of it, and there's another car which is going a little bit more slower and there's a box at the end of it. So what's happening is the energy that the car has is getting transferred to the box. So you see, this is the first case, the box moves a greater distance, or there's a greater displacement. Why does it displace more? Because it has more kinetic energy. So more work is done on the box. In the second case, however, because it has less energy, it's like lethargic for a minute there, and because of that, the displacement is also less. So the box apparently moves a lesser distance. Why? Because it has lesser kinetic energy. So greater the kinetic energy, or greater the velocity, greater would be the kinetic energy. In other words, it's directly proportional. Now let's say this is another example. Same box this time, but this time there's a truck and there's a bicycle. So you see that, let's say that both of them are moving at the same velocity. Both of them are moving at, let's say, 10 km per hour. Both of them are moving at 10 km per hour. But you see this, in the first case, there is displacement. The box is getting moved. But in the second one, there's no movement at all. Why? You could say inertia, but no guys, it's because of the fact that the mass of the truck is far more greater than the mass of the bicycle, and the person together with it, the mass is quite comparatively less. And because of that, the displacement is also less. So because it has greater mass, it has greater kinetic energy. More is the mass, more is the kinetic energy, more is the work done on the object, and so you can say that kinetic energy is directly proportional to mass. And because of this, guys, mathematically, let's try to express this. All right, so let's say there's a box or there's a ball on which you're applying a force. All right, and the ball is getting displaced by a distance s. All right, so it's going from point A to point B. It has an initial velocity of 0 because the ball was initially in the state of rest, and then it has a final velocity v. Now we know that the work done is what the force into displacement, and energy is what the capacity to do work. So I can say that kinetic energy or work done is equal to kinetic energy because it is the capacity to do work. And what is the formula for work done? Work done is force into displacement. So F into S is what you can get. Now, according to Newton's second law of motion, we know that force is mass times acceleration. Mass times acceleration. So m into a. So I'm going to substitute that over there. All right. In place of F, I'm going to substitute m into a. And according to the equation of motion, we know that from the third equation of motion, you know the initial velocity, you know the final velocity, you know the acceleration also from the second law of motion, so Newton's second law of motion. So you can say that you can use the third equation of motion, that is v square is equal to u square plus 2as, or v square minus u square is equal to 2as, and find out the value for s. So rearrange the equation. So what are you going to get? You'll get it as v square minus u square is equal to 2as. So what is s? S is equal to v square minus u square divided by 2a is what you can get. Substitute this and this in the first equation. So what are you going to get? So kinetic energy is equal to m into a into v square minus u square divided by 2a. A gets cancelled. So what are you left with now? M into v square minus u square whole divided by 2. Alright. Now multiply. So here's the thing, guys. You know that the initial velocity is 0. Remember, the ball was initially in the state of rest. So multiply m inside. So what do you get? M into v square divided by 2. In other words, half mv square is what you get. Because the initial velocity is 0, this is what you get. Simple. This is how you derive it, guys. It's an easy 3 mark right there. So kinetic energy, which can be written as E into E subscript k, is equal to half mv square. So kinetic energy is directly proportional to the mass. as well as the velocity. So let's solve some question. Here is another one. An object of mass m and velocity v has kinetic energy of 200 joules. Find the new kinetic energy if the mass of the object becomes doubled and the velocity still remains the same. So for the first one, guys, let's try to write down the given data. So kinetic energy is equal to 200 joules is what is given. So what is the formula for kinetic energy? Half mv squared. Now the new kinetic energy, I'll just take it as ke dash, is equal to half. The mass becomes double, so it will be 2mv square, right? So I'll just take 2 to the other side. So I'll just take the 2 outside. So what are you going to get? 2 into half mv square. Now what is half mv square? That's 200 joules. So 2 into 200, what are you going to get? 400 joules is the answer. That's all. Simple. Very, very simple question, guys. And the answer is 400 joules. That's all. Option C is the right answer. I hope you got this right. If you did not, this is how you do it. Wait, let me just go back to that. This is how you do it, people. So just substitute the values and get the answer. That's it. Moving on, guys, the next thing we're going to talk about is potential energy. Potential energy is nothing but the energy possessed by the body by the virtue of its position or the state of rest. That is what is potential energy. So the energy possessed by the body due to its configuration or position relative to the ground or another object is what is called as potential energy. And the formula is going m into g into h, where m is nothing but the mass, g is the acceleration due to gravity, and h is nothing but the height. Now let's say there are there's a box, and you're moving from A to B. All right. So for the first one, you're using a straight path. So you're just moving it upstairs, or just taken up straight up, and the height from the ground is h. For the second one, you're going to the path taken is a little curved. It's an indirect path. Now, in both the cases, the work done would be the same, because when you talk about potential energy, which is generally represented as U, is equal to mgh. So it does not path dependent, guys. It is not path dependent. It's only depending on the height. In both the cases, the height is still the same. The height is still the same itself. So the potential energy in both the cases would actually remain the same. It doesn't matter whether the path chosen was different. Even if it takes, even if it takes another path and brings it over here, it really doesn't matter. The height is the final, and the initial height is what matters the most, or the maximum height the body has reached is what matters the most. And in this case, it's going to be the same, right? So that is potential energy, people, in simple words. So potential energy is the energy possessed by the body by the virtue of its position or configuration, and the potential energy of an object is equal to EP is equal to mgh. The potential energy depends on the initial and the final position of the body and not on its path. It really doesn't matter. So let's try to solve another question based on this. All right. Here's another one. An object with 100 Newton weight is raised to a height of 15 meters. Find the potential energy possessed by the object at that height. Also find the new potential energy if the same object is raised half of its original length, and if the same object is raised 3 times its original length, given that g is equal to 10 meter per second square. Whoa! I love this question. Let's try to do this. All right. So the first one, guys, the height is given as weight is given as height is 100 newtons. Height is given as 15 meters. I don't need to change this at all. The units are pretty much the same. For the first one, guys, let's try to find out what is the first. I'll just take it as, we'll take it as U1 itself. Potential energy U1 is equal to M into G into H. So what is M into G? Weight is nothing but mass times acceleration to gravity. So M into G is directly given as 100 newtons. So 100 into 15, what is it? 1500 joules is what you're going to get. Now for U2, the height is a little different. So what is the height now? Height has actually become half of it. So that's 15 divided by 2. It's nothing but 7.5 meters is what you're going to get. Substitute the value, guys. 100 into 7.5. That's what? 750 joules. That'll be the answer for the second one. For the third one, they increase it 3 times more. So what is the height value over here? 3 times. So 15 plus 15 plus 15, that's 45. 45 meters is what you get. Substitute that over here. So 100 into 45, that's 4500 joules. That's it. So the answer to this question is 1500, 750, 4500 joules. That's all, people. If you're enjoying the session so far, hit that like button, subscribe to the channel as well. And yes, guys, if you would like to learn these kind of topics in detail and learn for gaining 100% knowledge and getting 100% marks in your exams, click on the link that is given in the description and enroll into the Vedantu Pro subscription course right now. Let me tell you what are the advantages. First of all, guys, you have unlimited live session. Unlimited, just like YouTube, but Much better, I would say. So yeah, unlimited live sessions with the highest level of quizzes, which will definitely help you to understand the concept better, but in a very fun and interactive manner. And these quizzes will also give you a unique opportunity to compete with the rest of the world and see what are your weaknesses and what are your strengths. You can actually know where are you lacking behind and what are the topics that you should be working on. So you'll be getting a detailed report on yourself. You'll be getting a detailed report card from us, and you'll also understand that these are the weaknesses and these are your strengths, and you'll have to work on these topics. And yes guys, every single live session is recorded, and the recordings are such a way that even while watching the recordings you can take the quizzes and check out the leaderboard. Like, how cool is that? While watching the replay you can take the quizzes and check out the leaderboard. That's just mind blowing. With this, people, you have some amazing content available to you on the for every single session. You can download all these premium content, every single handwritten notes, everything that is put into the class will be available to you, so you don't have to worry about anything ever again. With this, people, I would say this is probably the best part, that every session will not just have the master teacher, but you'll also have the class teacher to help you clear every single doubt of yours. Instant doubt solving, unlimited instant doubt solving inside the session, right there, right then, real time. Does not matter how many doubts you have, everything will be cleared inside the class itself. And yes, do not worry, you have some amazing tests and assignments as well, and these tests and assignments will definitely help you prepare better for the exams and make you better every single day. Don't you want that? I'm pretty sure you do. So what are you supposed to do? Click on the link that is given in the description, people. So let me just show you what and how does it really work. So first thing first, go to the Vedantu channel. So I've already opened up one of the videos over here. So click on, so let's say that, look, this is the Vedantu channel. Let me just mute the video first, so that there'll be no distractions. So yeah, so click on any of the videos that are already playing. So this is my video that is going on right now. So click on read more. Click on subscribe to Vedantu 9th and 10th right now. Just click on it, guys. It'll directly take you to the link. So yes, okay, first of all, subscribe to the channel. And yes, okay, I think there's some issue there. So anyways, I'll just show it to you guys. So show more, go to subscribe to Vedantu Pro right now. Click on subscribe to Vedantu Pro, and this is what you can get. Now let's say that you are in 9th standard and you're moving to 10th, or you're already in 9th standard. So if you're 9th moving to 10th, or if you're 8th moving to 9th, if you're 8th moving to 9th, then click on CBSE 2022. This is the full year course where you have all the schedule available to you. All the teachers will be teaching you with detailed explanation of every single topic. So if you go for the 1 month program, guys, that's 2,700 rupees. But if you click on proceed to pay, you get a discount. Little surprise for you guys, 540 rupees discount, and the price drops to 2,160 rupees for 1 whole month. Now if you go for the whole year course, that's 32,399 rupees. But if you click on proceed to pay, you get a flat 6,479 rupees discount, and the price comes down to 29,990 rupees for the whole year, for revision, for all the courses, everything, the best of the best there is to there is in technology, all of it at your fingertips. All right, now if you go for let's say that you're 9th moving to 10th, then click on CBSE 2022, and yes guys, you can see all the details over here, all the teachers, all the results that we've achieved last year. If you go for the 1 month program over here, it's 3,300 rupees. Again, the price drops on to 2,640 rupees. You get a flat 660 rupees discount. And if you go the whole year program, that is till March 2022, again, the base price is 38,880 rupees, but you get a 7,776 rupees discount, and the price drops on 31,104 rupees. Again, guys, all the subjects with test, assignments, class teachers, with the best of technologies, all of it available for you at your fingertips. So what are you waiting for? Enroll now, people. The seats are limited, but yes. And if you talk about the value for money, guys, just think about it for a second. For 1 month, if you go for the 1 month program, So these are the base prices of it. Like I just told you, if you go for the 1 month program, that's 200 sessions in 1 month. That means that per session you're paying 12 rupees. But if you go for the long-term quest program, that is still March 2022, that's 2,400 sessions in the 12-month duration, which means that per session you're just paying 10.7 rupees. And if you go for if you're, let's say that you're in 9th moving 10th, sorry, 9th moving 10th, this is what it is, guys. So the base price of that will be 2,160 rupees, and again it'll be 10.8 what you're going to pay for per session. And if you go for the year-long program, that's 10.7. Again, you can check out all the details, it'll be given to you in the description. And that 10 rupees is basically not less, but it's equal. Okay, yeah, it's actually Maggie's 12 rupees now, so it's less than a packet of Maggie, which takes 2 minutes to cook. Right, guys? This is for a year-long program. Link is given in the description. You can check out the link. Alright, so that's it, guys. Let's get back to the topic. Let's talk about conservation of energy. What is conservation of energy? See, guys, according to conservation of energy, energy can neither be created nor destroyed. It can only be transferred from one form to another. What do we mean by that? Let's say this, guys. Let's say there's a ball which is at a height h from the ground. So it is at a height h from the ground, and it has a mass m. Initial velocity is 0 because it's in the state of rest. And you drop that ball. All right. Now, what you're going to check is that what is the kinetic and potential energy, or in other words, what is the mechanical energy over here? What is the total mechanical energy over here? And what is the total mechanical energy just before it's about to hit the ground? So when it's in midway, that is when it's h by 2, or when it's half the distance. And the other is when it's just about at the ground. And then when it's in the height h. Now, when it's at its maximum height, at this height A, at this position A, because the initial velocity is 0, we know that kinetic energy is what? Half mv square. Because v square or u square is 0, kinetic energy in this case is going to be 0. But the potential energy is going to be maximum over here. So what is the formula of potential energy? U is equal to mgh. So m into g into h, because the height is h, that is the potential energy. So what is the total mechanical energy? The total mechanical energy, that is T, I'm just going to take it as Tm because I don't have enough space to write. So that's kinetic energy plus potential energy. So that's K plus U, which is nothing but 0 plus mgh, which will get it as mgh. Now, when the ball has moved a certain height, certain distance, x, right? So what is the height from the ground? It's h minus x. The total height is h. The ball has moved a distance x from its initial position. So what is the height from the ground? It's h minus x. Now the potential energy the ball had. So as the ball is dropping down, the potential energy is getting converted to kinetic energy because the ball is moving now. So what is the kinetic energy? So kinetic energy in this case is what? It's nothing but mgx. Why mgx? Because of the fact that half mv square is the formula. Now again, in this case, what do you call the velocity is to find out the velocity, we're going to use the second equation of motion, third equation of motion. V square is equal to u square plus 2 as. We're going to use this formula, and we're going to get when you do the calculation, you can get it as mgx is what you're going to get for short. You can check out the calculations later and you'll be able to find that this is what you're going to get, right? When you substitute the values of v square, you'll get it as mgx itself. So this is your kinetic energy. Now potential energy in this case, because it has moved a certain height, the potential energy, because height is now h minus x, you'll get as mgx minus x. Now to find out the total kinetic energy, again total kinetic energy is what? Potential plus kinetic. So kinetic and a total mechanical energy is what? Mgx plus mgh minus mgx. So you're going to take the mg and multiply it inside. So this is what you're going to get. So mgx gets cancelled. So what are you going to get? You're going to get as mgh itself. So this clearly proves that no matter where the ball is at, no matter what height it is, the total mechanical energy of the system is always conserved. Now for the third case, again, in this case, just before it's about at the ground, the height from the ground is 0. So potential energy is going to be 0 because h is 0. But the kinetic energy is going to be maximum. Again, in this case, the kinetic energy will find as mgh, and so the total mechanical energy again would be what? Mgh itself. So no matter where the ball is, even if it's over here or here, it does not matter. At any point in time, at any point from the ground, the total mechanical energy of the system is always conserved. And you have to understand this, guys. As the ball is dropping down, as it's going down, the potential energy is slowly decreasing as the height is decreasing, and the kinetic energy is slowly increasing because the velocity of the ball is actually increasing. All right. So here there's no destroying of the energy; it's only getting converted from the potential energy that it already had to kinetic energy. Now this is a graph which is a very important graph that shows the variation of kinetic and potential energy with height. So this is basically energy versus height wala graph. So you can see this. So height, as the height increases from 0, the potential energy slowly starts to increase, and as the height decreases, the kinetic energy starts to decrease as well. So kinetic energy is lowest at its maximum height, and as it is, as the height is decreasing, the kinetic energy is also, increasing. But the total kinetic and potential energy will remain same. So mgh will be the total kinetic and potential energy, that is the total mechanical energy of the system, will always remain constant, which is nothing but mgh itself. So as the height is increasing, the potential energy is increasing, and the kinetic energy is slowly decreasing. Alright guys, so that is what I would like to talk about. See, you see this, guys? So at its maximum height, the kinetic energy is minimum, but its minimum height, the kinetic energy is maximum, because it's slowly, in other words, it's decreasing. As the height decreases, the kinetic energy decreases. That's all. So yeah, guys, that proves your law of conservation of energy as well. This is what it is. According to the law of conservation of energy can neither be created nor destroyed. It can only be transferred from one form to another. That's it. Here's another one, guys. A ball of mass 2 kg is thrown up with a speed of 10 meters per second. Find the kinetic energy of the ball at this time of throwing, and also find the potential energy of the ball at the highest point. First of all, find out the kinetic energy. So mass is given as 2 kg. Velocity is given as 10 meters per second. So half mv square is your kinetic energy, which is what? Half 2. Sorry. I'll take it as 10 into 10 into 2. Okay, substitution. So yeah, guys, 2 gets cancelled, so what do you get? You'll get us 100 joules. Now, when the ball, see, the velocity of the ball, so the kinetic energy processed with the ball is 100 joules. When it's at its maximum height, all that kinetic energy gets converted to potential energy. So at its maximum height, this entire kinetic energy gets converted to potential energy, because it's, law of conservation of energy. So what will be the potential energy then? That will also be 100 joules itself. That's all. So 100, 100 would be the answer for this question. That's all, guys. Alright, people, towards the end, last 2 topics, power and basically commercial unit of power. What is power? Is nothing but the rate of doing work. In other words, work done by time taken is what is called as work. The rate of doing is the rate of energy transfer of energy is what is called as power. Power is equal to work done by time, which is nothing but W by T. The unit of work is what? It's nothing but Newton meter, or you can write it as joules per second. So joules per second, we can also write it as watt, named after James Watt, the great scientist James Watt. So it was a tribute to him. So power, the unit is watt. So when is power said to be 1 watt? When work done is said to be 1 joule, or when power is said to be 1 watt, when the work done on an object or on a body is 1 joules in 1 second. That is what is called as 1 watt. So yes, guys, let's do another problem as well. Here's another one. Calculate the power of an electric motor that can lift 800 kgs of water to store in a tank at a height of 1500 centimeters in 20 seconds. Take acceleration to gravity is 10 meters per second square. Let's go ahead and do this one also, guys. Go on. So mass is given as 800 kg. Height is given as 1500 centimeters. And time taken is given as 20 seconds. Whoa. Alright, first of all, guys, convert the units. Alright. So first of all, height, convert this to meters. So 1 meter is equal to 1000 centimeters. So that's 15 meters. And yeah. Alright. Time taken. Let's keep it like that itself. Now, you're supposed to calculate what is the power. Power is equal to work done by time. What is the formula for work done? It's nothing but mgh divided by time. So what is mass? 800 into 10, height is 15, divided by time taken is 20. So 0 gets cancelled. 24800. So 400 into 15 is what you get. So when you multiply 400 15, you'll get it as what? It'll get as 6000 watts or 6 kilowatts. That's it. So that would be the answer, is 400 4.2002, yes, that will be the answer. So you'll get a 6,000 watts, which is nothing but 6 kilowatt. That's all. So that is the answer, guys. Last topic, commercial unit of energy, which is another very important topic. I know you've been bearing me for so long. This is the last topic, guys. Let's just quickly finish off as well. So we know that, see, all this while we've been talking about joules, right? Joule is a smaller unit of power, and we know a smaller unit of energy, smaller unit of work done. It's something that can be easily measured. But if you have a bigger unit, or if you talk about energy consumption at homes and stuff, it's much more larger. So representing them in joules is not a practical solution. So over there, the bigger unit of energy that we use to to represent what is the consumption of energy, we use something called as kilowatt hour. So 1 kilowatt is nothing but 1000 watt, and 1 kilowatt hour is equal to 1000 watt in 1 hour time. So what is 1 hour in terms? So if you have to convert it to joules, what is it? 1000 watt into 1 hour. So what is 1000? So watts is what? Joules per second. So 1000 joules per second, and 1 hour is equal to what? 3600 seconds. So 3600 into 1000, you'll get as 3.6 into 10 to the power of 6 joules. So if you're ever asked to convert, 1 kilowatt hour, if they ask you to represent in terms of joules, or if they ask you to represent in terms of they've given you the the energy consumption in terms of joules, and you're asked to convert to kilowatt hour, so divided by 3.6 into 10 to the power of 6 joules. That's all. So 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. So this is the electric meter that every one of us have at home. Now these days it's more digital than analog. This is the older version of it. But yeah, this is the one that is used to measure the electricity consumption in terms of kilowatt hour. Again, it's measured in terms of kilowatt hour itself. So kilowatt hour is the unit of energy that is used to express the energy consumption in households, industries, and commercial establishment. So let's do this question as well, guys. Here's the last one. An electric heater of 1000 watts is used for 2 hours in a day. What is the cost of using it for 1 month for a month of 28 days? And if 1 unit costs 3 rupees, what would be the cost? Options: 196, 249, 168, or 128 rupees. Let's try and do this, guys. Come on. So the power consumption is given as 1000 watts. Every day time taken is basically 2 hours every day. They're using it for 2 hours. And for 28 days, let's take it slow. So energy is nothing but power into time. So what is that? 1000 into 2, which is nothing but 2000 watt hour. 2000 watt hour is what you get. Now convert this to kilowatt. So that's divided by 1000. So that's 2 kilowatt hour is what you get. Now, if you're using it for 28 days, how much will the total consumption will be? What total energy consumed would be what? It'll be 2 into 28, which is what? 56 kilowatt hour is what you get. Now, if you're supposed to find out the cost, what will be the cost then? Total cost will be what? Total cost will be, if 1 kilowatt hour, if 1 unit is what? 1 unit is nothing but 1 kilowatt hour, right? So 1 kilowatt hour is nothing but 1 unit. So remember that, guys, 1 kilowatt hour is nothing but 1 unit. So here, if you're asked to convert, if you're asked to find out the cost, so what will be 56 into 3, which if you multiply in unit is 168 rupees. So the answer is 168 if I'm not wrong. Yeah, that's the answer, guys. So that's all, people. That is all for today. Thank you for joining. That was the entire chapter of work, power, energy in one shot. I hope you enjoyed it. I know it was a long session, but nonetheless, guys, it was for you guys. So yes, do not forget to like, share, and subscribe, and reward us, not reward us, but show us your support, show us your love. That's all I'm asking. Thank you for joining, guys. Catch you guys in the next one. All the very best for your exams. Rock it, do well. And if you need any help, you can also always reach out to me at anoop.manoharan@vedantu.com. Thank you, guys. See you guys in the next one. Until the next time, this is Anoop signing off for the day. Have a great evening ahead, guys. Thank you and bye-bye. Take care.